Okay, second degree trig equations brings us into like the quadratic world. So factoring or quadratic formula type stuff. Yeah, that's the one. That's what I'm talking. So before we add trig into it, just to remind you how we would solve for x in a quadratic that's factorable, is we would factor it and tee it up, right? So this would be x minus 4 times x plus 1. Hopefully we don't have to review factoring. And then when you tee it up, you get x equals 4 or x equals negative 1. So now let's look at that parallel in the trig world. If we were factoring, first of all, can we pick up on the fact that this is a quadratic? What is the giveaway that that's a quadratic? The squared, the tan squared, exactly. So we'll try factoring first. I'm going to make these a little bit bigger because I'm going to have to write the word tan in there. But what times what gives you tan squared? That's tan times tan, right? And then just like with regular factoring, you're looking for what multiplies to get negative 4, so that when you do your outer product and your inner product, you get negative 3 tangents. So again, that'll be minus 4 and plus 1. So your outer gives you 1 tangent, your inner gives you minus 4 tangent, 1 tangent minus 4 tangent is the negative 3 tangent in the middle. So far, so good? Tee it up. So you'll actually want to tee this up, set each piece equal to 0, and just solve. So add 4 to both sides here, and we have that tangent of theta equals 4. And subtract 1 from both sides here, and you get that the tangent of theta equals negative 1. Now, one of those answers, one of those equations, is going to have, we're going to use a chart. Tangent is your y-coordinate divided by your x-coordinate. When is your y-coordinate divided by your x-coordinate going to give you 1? We'll talk about what we need to think about for the 45-degree angle. Does everyone see that? Or is it 2 over 2 divided by itself? So your reference angle for this one is 45 degrees, and we are in degrees, so that's good. We'll keep it in degrees. So your reference angle is 45 degrees. But we're looking for where tangent is negative. So all students take calculus. We can cross out quadrant 1 because tangent's positive there, so we have no solution from that quadrant. We can cross out quadrant 3 because tangent is positive there, so we won't have an answer there. Tangent is only negative in 2 and 4. So if 45 degrees is your reference angle, and this is your frame of reference 180, what's the angle in that quadrant? 135, right? 45 degrees shy of 145. So again, to get that, think about how your rotation, look up the board, think about how your rotation opens. We're at 0, and we're going up to 180, but that will have been too far, so we need to back it up 45 degrees. Gives you 135. Yes? I used my chart. I needed to know when tan equaled 1, essentially. I'll worry about the negative later. The negative doesn't come into play till I'm starting to consider which quadrants to go into. The reference angle is just when does tangent equal 1. So you have your chart. Either know your chart, know your values, or I used that version of the unit circle, which you weren't here for when I explained yesterday, but your chart, essentially, Brock. Oh, I'm going to get there. So this will be 135 degrees is one answer. And then to get in the fourth quadrant, I continue my rotation. If I go the entire way, I'm at 360. That means I've gone too far, so I have to back that up 45 degrees, which is 315. So those are my two answers for this tangent one. For the other tangent one, if you think about the chart, there's no 4 on it, right? Tangent never equals 4. At least, I mean, it will, but not at any one of our critical degree measurements. So you have to use your calculator here. You'll do inverse tangent of 4. And when you do inverse tangent of 4, you're going to get something in which 2 quadrants? When you do inverse tangent, you're always given an answer in which 2 quadrants? 1 and 4. So the answer the calculator gives me is going to be between negative pi over 2 and positive pi over 2. My mode should be what? Degrees. So inverse tangent of 4. So it's given, we'll just round it to the nearest degree to keep it simple, 76 degrees. So it's giving me a reference angle of 76 degrees. When is tangent positive? First quadrant, right? Not the second. The third quadrant, not the fourth. So a reference angle of 76 in the first quadrant is what? 76. And a reference angle of 76 in the third quadrant, how would you get that? 180 plus 76, right? Because tangent is positive. And the 2 quadrants where tangent is positive is 1 and 3. So we're doing the same thing. The thought process, that whole conceptual process, the difficult part really is you're going to spend more time practicing that. It's just we have to get past the quadratic part first, which I don't think is too difficult. Well, right, because when you factor it, you're going to have too many equations, and each mini equation usually has 2. Sometimes one will have 2 and the other one might only have 1, if it's one of those extreme cases of 1 and negative 1, but usually 4. Okay? All right, next one. The factoring on this one is different. It's actually easier, but people aren't used to it as much, so they forget. But how do you factor something like that? Take the x out. It's just a GCF. So you take out an x, you're left with x minus 1. You tee it up. Okay? We're not really here to review those solutions, but go over here. You have a sine squared minus a sine equals 0. So we can factor out a sine. And we're left with sine theta minus 1. And then you tee this up. So this is really technically the first factor, right? You could put that in parentheses if you wanted. Either sine of theta equals 0, or the sine of theta minus 1 equals 0. And we'll start with this one. When does the sine equal 0? Right, so this is one of your quadrantal angles. It's not going to give us a reference angle in between 0 and 90 again. So if you look at the pie chart over there, sine is your y-coordinate. That equals 0 at a 0 radian, and again at a, or do you want to talk degrees? When it's sine 0, then one is the y-coordinate of 0. That's happening here at 0 degrees or 0 radians. And it's also happening here at 180 degrees or pi radians. Yeah. It's consistent in terms of pi. Our two answers for that are going to be 0 and pi. I really like the zeros and the ones are definitely, I really like that. So just you see that sine has to equal 0, right? And you know that sine is your y-coordinate. So those are the only 2 points where the y-coordinate is 0, the ones that I circled up there. That's happening at 0 degrees and 180 degrees. So if it was a degree interval,
0 degrees and 180 degrees would be these two answers. Since it's, in terms of pi, it's just 0 radians and pi radians. Yeah. Okay? For this one. Oh, she does include 2 pi. Usually they don't. So, do you see how she has a less than or equal to sign on the 2 pi also? Everybody see that? So even though 0 and 2 pi are coterminal, we're going to include that too. She actually does that on the 360 as well. I don't think textbooks normally do that, but I'll look. It might just be a typo too, but pay attention to that, because if it is included, include it. But typically it's really not. All right, on the second one, when does sine of theta equal 1? And this is one of your extreme cases. You're looking, if you're using that version of your chart for values, you're looking for when is your y-coordinate 1? 90 degrees, which is how many radians? Pi over 2, and that's your answer. So this is one of these that would typically only have 3 solutions if she hadn't had that little symbol there. I'll have to. You got through that one? Yeah. Okay. See, this is it. On the one hand, this is the only thing Maddie understands, and you're hating it. We're going to have a 1 question, or 1 or 2 question, like, real short 5, maybe 7-minute quiz tomorrow on just solving a regular one from like yesterday and a quadratic one from today, just to see where we all are. I can't remember what you said. All right, number 3. Is it factorable? It is. Try for a minute, factor that on your own. Are you already done? The factoring? JR, would you like me to do this with you? We'll factor together. What times what gives you cosine squared, JR? Did you factor it okay? That's all I asked you to do. Baby steps here. Baby steps. Yeah, see, if I'm just taking a quick time out, if I'm looking in a typical textbook, when they ask you to solve these, they're usually not going to include 0 and 2 pi on both ends, because 0 and 2 pi are just coterminals to each other. You see? So it's really only going to even bother you if 0 happens to be an answer. Because if 0 is an answer, then 2 pi will be an answer too, if it's included with a less than or equal to symbol. Yeah, I won't include it. I'll always tell you to get rid of it. It shouldn't be there. I just want you to get through the factoring. Did we get through the factoring? Mike, what'd you get? I think you even went too far. You already teed it up. Prior to that, what do your factors say? So those multiply to -6, and then -3 cos plus 2 cos is -1. Perfect. So when he teed it up, he got cosine of theta equals -2, and the cosine of theta equals 3. I have great news for you. Cosine values always have to be between what two numbers? Cosine values always have to be between 1 and -1. If you're looking for where the cosine equals -2, it's never going to happen. And if you're looking for where the cosine is going to equal 3, it's never going to happen. Okay? Number one, you wouldn't be able to find a place on that unit circle where the x-coordinate is 2 or 3. So you'd have a trouble using that chart anyway. So if you decided to go to your calculator and you did inverse cosine of -2, you're going to get an error because it can't be done. There is no answer. So this one has no solutions. So that's exciting. Jump on that opportunity. If you see sine equals or cosine equals anything outside of -1 to 1, you're done. Sine and cosine. Like, think about your sine graph. Sine graphs also go from -1 to 1. Did I just do that backwards? Boy. Tangent graphs, you can't do that, right? Because remember what tangent graphs look like? This kind of crazy thing? Tangent graphs hit everything, unfortunately. You can't just ditch those. You would just do inverse tangent on your calculator, like we already did one. When does the tangent equal 4? We did get produce answers for that. All right, the last one. Oh boy. I'm going to cross multiply. No. It'll be fine once I cross. I could treat it as a rational and subtract that over and get a common denominator and then drop it, or I could just cross multiply. Okay, so you could subtract your 1 over and then factor, because it would be tan squared minus 1, which is the difference of perfect squares. Or, as Andrew keeps saying, you could just take the square root of both sides. And whenever you take the square root of both sides, what symbol do you have to remember? Plus or minus 1. So we have two situations to consider. When does the tangent equal 1? And when does the tangent equal -1? Luckily for all of them, it's the same reference angle, right? Tangent equals 1 at what reference angle in degrees? Correct. And because we have the +1 option and the -1 option, all 4 quadrants are covered, right? The +1 covers quadrants 1 and 3, and the tan equaling -1, whoops, I forgot my theta, will cover 2 and 4. So if we just grab the 45-degree reference angle in each quadrant, what's this one? 45. What's this one? Nope. 135, because we were at 180, we have to subtract. Maddie, I don't like that. Did you give me the other quadrant? Okay. So then 180, when you add on 45 to give me this one, will be the 225. And then this one will be the 360 minus the 45. So we still have 4 solutions. 2 were for the +1, 2 were for the -1. Are we feeling good? We're feeling good.